So now let's start working on our chats map file. And this is just going to allow us to keep track of all the chats our users have created. So let's go ahead and add in some use statements that we're going to need. Standard collections HashMap and standard sync arc and mutex. And now we can create our ChatTracker struct, which is going to be a mutex on a HashMap that has a arc string and an arc chats. And our ChatTracker is obviously a mutex protected hash map that is going to map chat names to the actual chats. So now we can start implementing a few methods on our ChatTracker, with the first one being new. So we can say pub effin new, and we're going to return a ChatTracker, and we have a ChatTracker mutex new, and now we have a new HashMap. And that's all we need to do here. So the next couple of methods that we're going to have are actually very similar to each other. So we're going to have pub effin find and pub effin find or new. Find is going to be used when we post, since we know the chat should already exist. And then find or new will be when we join a chat. If it exists, join it. But if the chat does not exist, then we want to create a new one. So let's start implementing find first. So we're going to take a reference to self, and then we're going to have a reference to a string. And then we're going to return an option to an atomic reference counted chat. So then we just have self lock unwrap get the name and then clone it. Cloned. There we go. And now for find or new, it's going to be very similar. So self name a reference countered string, and we return a reference counter to chats. And then lock dot unwrap entry name dot clone, or insert with arc new chats new name dot clone. And let's make this follow convention, cargo format, so everything looks good there. So again, these two are pretty straightforward in what they are doing, and that's all we need to do in our chat maps file. So now we can hop over to our connections and start working on handling our client's connection to the server. So let's go ahead and add in some statements that we know we're going to need. So we'll have async standard IO buff reader, async standard net TCP stream, async standard prelude, give us everything, async standard sync arc, and then chat utils self chat result, and then chat client server. So now we are going to create a function called handle, pub async fn handle, and handle is going to take care of each incoming connection. So our implementation for this will actually be pretty straightforward. So we're going to have a socket of type TCP stream chats, which is going to refer to our ChatTracker. And now we want to return a chat result. So one thing that we're going to need is a struct to handle outgoing messages. We will take ownership of the TCP stream and then wrap it inside a mutex so that only one task can use it at a time. We will have two methods associated with it, new and send. So let's go ahead and add these in. So we're going to have a struct, and we're going to call it leaving, and it's going to be a mutex wrapped around a TCP stream. And we have a couple of methods associated with it, such as new and send. So let's go ahead and add in new, and it's going to be TCP stream leaving, and then in here we're going to return leaving with a new mutex around our TCP stream. So now we're going to have an asynchronous function called send that refers to self and then packet of the server, and it's going to return a chat result. So now we need to get the lock, self 0 lock await, and now we can send JSON a reference to our lock, to what our lock has, and so we need to dereference it and then pass in our packet and await it. So if we look at what's going on here, we're taking our lock and our packet and using the utils send JSON. And so we see we have leaving, which is a mutable generic O, and then our packet. So everything is lining up accordingly. So now we want to lock, flush, await, and then return OK. So now we can implement our core logic inside of handle for our server's connection. The logic that we're going to implement is actually going to look very similar to our client's messages function here. So this is something that we've relatively have already done before, so let's just go ahead and start implementing it. So we have a leaving socket clone. So we have a new atomic reference counter of leaving, of our leaving struct, excuse me. And now we're going to create a buffered on our buff reader, new on our socket, and then from the client we want to receive buffered, and then while let sum request result equals from client next await let request equals request result, and now we will say let result equal match on request, and this is where we've kind of already have done this before in our messages. So we're going to say client join chat name, and now we'll say let chat equals chats finder new, which we had recently implemented, and then on chat name. So we want to see if that chat already exists, and then join it. And now we can return OK. Now we have client post for when we want to post messages. We have chat name and message, and we're going to match on chats find and chat name. And then inside here we have some chat.post. We want to post our message. Return OK. Otherwise, none. And now we want to return our error. Chat does not exist. The chat name. Start ending it off. And then if let error message equals result, let report equals server error message. So what we're doing here is we're really just tying everything in to what we have already implemented into our server's logic. And I need to move this up to right there. And then down here we return OK. And now that we have our connection implemented, we can tie all of this logic in to main. That way we can run our application. So we will do that in the next lecture.